Hi, we're going to do question 139 and 140. So let's do it. A histogram displayed below in minutes has information in regard to a sample of 26 chimpanzees. And we look down here and they want us looking at a box plot. Well, a box plot is merely a 5-number summary. So that's my min, my max. Quarter 1, quarter 2, also known as my median, and my quarter 3. So if I can identify using this raw data, these 5 pieces of information, I can pick out which one is accurate. So ultimately, if you know how to make a box plot, you'll know which one was made correctly, and that's what they're asking. So when I look at this number 26, I say to myself, well, the median would be in the middle. So when I take the number 26, I get 13. So that would mean 13 lower numbers, 13 so 13 of the chimpanzees had lower times, 13 had higher times. That's what the median is. To find the median, I can either count down 13 from the top, and also it would probably take the same amount of time. I can count up from the bottom. So either one is perfectly okay. Also, I'd like to find this quarter 1, quarter 3, because that's going to be the face of my box here. That's this face. Here's my quarter 1, median, quarter 3, my min, and then this is a little weird one. This is my max, not including my outliers. So they did us a favor here. They went ahead and followed the formula for outliers and found that since this value that's somewhere between 90 and 100, since that exceeded that, they've put this as an outlier. So that's technically called a modified box plot. And notice sometimes it's a dot or an asterisk. So, and all that's consistent on there. So we can't really discredit any of these just for the outlier. So let's go ahead and calculate this. But now I need to separate this lower half it again. So that would be half of 13. Would give me 6. So this would be the lower quarter. And one number would be in the middle. And then I'd have 6. So that number right there, or 7 up from the bottom, would be that quarter 1 number. And then again, the top half would separate the same way. This number in the middle of my top would be quarter 3. So that's how it would break out. So working from the back, my max is right here between 60 and 70. So my max is between 60 and 70. Let's see if we can simply eliminate there. That max is not between 60 and 70, so B's out. That one is between 60 and 70. We like this max. C is between 60 and 70, and all the other ones are messed up. So definitely my max was a good way to figure out, eliminate just these 2 middle ones. Now let's look at my min really quickly. They both have the same min, so the min is between 0 and 10. And so the only difference between these 2 graphs is my median, the number in the middle. So it looks like I'm going to have to go back to my plan, either counting up from the bottom or down from the top. So this is 6, 7, 8, 9, 10. These are the 10 lowest minute monkeys. And then this would be 16. So 13 would be somewhere in here. 10, 11, 12, 13. So the median is right here. Notice the median is between the number 20 and 30. So when I look at this graph, it's definitely true that D has a median somewhere between 20 and 30. There's my answer. Let's go to the next question. When performing a test of significance about a population mean, when we do a T-distribution instead of a normal distribution, which of the following is appropriate for an explanation? Well, what we always say is, why do we do a T? When the standard, this sigma, standard deviation of The population is unknown. So I am loving D. However, you can see somebody already crossed it off because they swapped out the word population, standard deviation of the population, for the word sample. Now, this is why we do it. And so nowhere in my explanation of why I do it is, the standard deviation they gave me was too big. That's a silly answer. So that's why that person crossed that one out. This one says the sample size. Well, this doesn't have to do with the sample size. It has to do with knowing the standard deviation. So the sample size not being large enough is not my reason. The sample does not follow a normal distribution. Okay, that's kind of interesting. When we take samples from a population, we know if we take enough of those samples, then my sample distribution will eventually be normal, whether the original information is normally distributed or not. This, though, doesn't really have to do with this, whether I'm using a T. So let's read C. That's definitely my answer. There's an increase in the variability of the test statistic due to us estimating the population standard deviation. So that's exactly why. That's exactly why we do it. We don't really talk about that a whole lot, but we proceed with the Tdistribution, which is a way to estimate this. And why do we have to estimate it? Because it's unknown. Well, anytime you estimate something, you're increasing the variability of the accuracy. And the whole point of your experiment is to come up with a test statistic. So when we go about estimating this population standard deviation, we are increasing the variability of the test statistic. That we do know, but we do it anyway because that's what we have to do when we don't know the population's standard deviation. That's all we have.